Now, when it comes to nonlinear inequalities, the normal rules of algebra of balancing both sides, they don't tend to really work because it usually involves more complex operations. When it comes to linear inequalities, we're familiar with, adding both sides, subtracting both sides. So things like, x plus 2 is less than 5. Oh, we're going to subtract 2 from both sides. That's perfectly legal. Oh, we're going to add 7 on both sides. That's a-okay. Oh, we're going to multiply both sides by 7. That is totally fine. Oh, we're going to divide both sides by 3. There's nothing wrong with that. Of course, there are little rules like if you multiply or divide by a negative number, you have to reverse the inequality symbol. All of that stuff is fair game, the basic arithmetic operations. But when it comes to more complicated functions, like, say, x squared is less than 4, we may be tempted to go, oh, we'll just take the square roots of both sides. But inequalities and more advanced operations, they don't play nice with each other. So how in the world are we supposed to solve inequalities that contain x squares or more complicated processes? The idea is a sign diagram, and that's sort of like the main idea of this topic. To solve a non-linear inequality, you will use a sign diagram. And non-linear just means if your problem is more complicated than just a simple x. If you notice you have exponents, more than one x's, or some other funky symbol, it usually means you have to use a sign diagram. If you forgot how to find a sign diagram, here's a quick review. You want to find the zeros or x-intercepts by setting equation or expression equaling to 0 and solve. So once your inequality has everything onto one side, you're going to pretend that it's an equal sign, set it equal to 0, and solve. Those will be the numbers you plot on the sign diagram. You're going to plug in a random number from the left interval. And if you don't know what I mean by the left interval, it'll make sense when I do an example. You're going to plug in a random number from the left interval into the expression to see if you get a positive or negative number. Once you plug in a number from the left region to see if you get a positive or negative number, you're going to fill in the rest of the sign diagram using multiplicities. Recall that at even multiplicities, the signs, the positive or negatives, do not change. And of course, the exact opposite happens. At odd multiplicities, the signs do change. Hopefully all of this would make a lot more sense once we do a particular example. So let's do several examples, one of varying types, just so you can see the whole gambit of what you might see. Let's start off with something simple, a quadratic inequality. Say, solve 2x squared minus 7x plus 3 is greater than 0. Okay. So the first thing we want is 0 on one side, which in this particular case the problem already does it for you. If you had extra stuff on the right hand side, you'd move it over to the left, but in this case we're okay because we do have the 0 on one side here. Next, what you want to do is find the x-intercepts, or find the 0. So on the side here, I suppose you could call this scratch work if you want. We're going to pretend that the problem says equals 0. Now, when it equals 0, you solve it like a regular quadratic. Solve by factoring, solve by completing the square, solve by quadratic formula, what have you. In this particular example, I picked it because he is factorable. If you forgot how to factor, just look up at the old topics and watch the videos. But we really need to be proficient at factoring at this stage. So this guy should factorize into 2x minus 1, x minus 3. And of course that gives us the x-intercepts of 1/2 and x equals 3. Once you have the x-intercepts, it's time to build the sign diagram. What you want to do is plot your x-intercepts relatively correct on the number line. You don't have to draw tick marks, but make sure they're in relative position to each other. So for example, 1/2 is, let's say it's over here, and 3 is over here. I always start with open circles. Whether or not these circles be open or closed will be depending on your inequality. Since it's strictly greater than, there's no or equals to line underneath it, it'll leave it open. If there was an or equals to line, I would fill it closed. But in this case, it will remain open. Now this is what I mean by plug in a number from the left region. Notice these two x-intercepts sort of cut the number line to 3 pieces. The left region, the middle region, and the right region. So what we're going to do is plug in just a random number from the left region, from the yellow region. We just need to pick a number that's to the left of 1/2. It doesn't matter what number you plug in. You can plug in a -3, a -7, a 0.0215. You can literally plug in any number you want to the left of 1/2. I think 0 is a very convenient number to plug in. So I'm going to plug in x equals 0 into our expression here. 2x squared minus 7x plus 3. And if you do that, you get 0 squared minus 7 times 0 plus 3. You get 3. Now, I don't care that the answer is 3. All I care about is the fact that it's positive. So we're going to put a little plus symbol here. Now, in theory, I could do the same thing in all 3 regions. I can plug in a number from the middle region and see if he's positive or negative. I can plug a number in the right region to see if he's positive or negative. But let's save us some time. Let's take a look at our scratch work here. So notice that if we were to trace the sign diagram from left to right, starting from the left here, and I'm going to approach the right, the first x-intercept I run across is the 1/2. We'll look at our scratch work. Where did the 1/2 come from? Here's the 1/2. He came from this part of the equation. His multiplicity will be the number of times we see this answer, or in other words, the exponent up here. I guess I should use a box instead of a circle because that looks like a 0. Well, what exponent is on top of this 2x minus 1? I hope we can agree that it is the number 1. Now again, just like with the number 3 in our sign diagram, I really don't care what the actual number is. All I care about if it's positive or negative. And of course, the number 1 is odd. So this x-intercept of 1/2 has an odd multiplicity. What does odd multiplicity mean? It means across the x-intercept, the signs will change. Let's take a look at the 1/2 on our sign diagram. See to the left, he's positive. Well, because 1/2 has an odd multiplicity, to the right, he is going to be negative because the signs need to change. Let's see that in action with the next x-intercept. So the next intercept is a 3. So I look at my scratch work. Where did I get the answer of 3? I got it from this guy. Where did he come from? He came from this parentheses here. So what is his multiplicity? What is the exponent on top of the parentheses? Again, it is 1, which means he has an odd multiplicity. Odd multiplicity, which means that the signs will change. So notice to the left, the sign is negative. Because the signs need to change, I know for a fact that this area is positive. That is how we use multiplicities to make a sign diagram. But we're not done yet because this is not an answer. To get the answer, you actually have to read the inequality. Read the part that has the inequality symbol. Notice it says greater than 0. Well, what type of numbers, positive or negative, are greater than 0? I hope that was a trivial question. Of course, positive numbers are greater than 0. So you're going to go on your sign diagram, shade the regions that have a plus sign above it. And we can clearly see that the left region and the right region have plus signs above it. That is the graphical representation of our answer. All you have to do is now write it in interval notation. So the left region, so what's our answer? Our left region starts at negative infinity, goes all the way to 1/2. I do have another region, so I need to connect them with a union. That right region starts at 3, comma, and goes all the way to infinity. Let's take a look at another example. This example is pretty boring because it was all odd multiplicities. Let's see what happens when we have an even multiplicity problem. So I'll be nice to you and I'll probably give you this problem already in factored form. Say I ask you to solve, I don't know, x plus 1 squared times x plus 3 times 2x minus 7 to the 4th power times x minus 4 to the 3rd power is less than or equal to 0. So the first thing I want to do is make sure there's 0 on one side, which it already has, so I don't have to do anything extra. Next, I don't really need to do scratch work for this because it's already in factored form. If the problem's already in factored form for you, you can just sort of dive into the problem. Let's find the x-intercepts. To find the x-intercepts, you just set each parentheses equal to 0 and solve. So for x plus 1 equals 0, I hope we can do some mental math. This x equals negative 1. For x plus 3 equals 0, hopefully we can do mental math. That's x equals negative 3. Let's do some more mental math. This is x equals 7/2, x equals 4. It's now time for the multiplicities. To get the multiplicities, you look at the exponent above the factor that gave you your answer. So I got the answer of x equals negative 1 by using this parentheses. That parentheses has an exponent of 2, which is even. So this guy here has an even multiplicity. Let's take a look at the next x-intercept. So this x-intercept of negative 3 came from this parentheses, so I look at his exponent, which we don't see anything, so it's an exponent of 1, which is an odd multiplicity. Move on to the next x-intercept. The next intercept is a 7/2. The 7/2 came from this parentheses, and that parentheses has an exponent of 4, which is an even number. So this is an even multiplicity. And hopefully I don't have to do any highlighting for the very last one. It has an odd multiplicity. So now it's time to make a sign diagram. Plot all your x-intercepts relatively correct in relation to each other. So negative 3 is all the way to the left. Negative 1 comes next. 7/2 is about 3.5, so we'll do 7/2 next. And then 4. Whether or not these x-intercepts are open or closed will depend on the inequality. See how the inequality right here specifically has a line underneath it, so I know they will all be closed. So now all I have to do is go fishing. I just need to find, plug in a number from the very left region. So I need to plug in a number to the left of negative 3, say negative 4. So let's do some scratch work here. I'm going to plug in a negative 4 into all of the x's in the original problem. So we have negative 4 plus 1 squared, negative 4 plus 3, 2 times negative 4 minus 7 to the 4th power, and then negative 4 minus 4. And again, I really don't care what the answer is. All I care about is if it's positive or negative. And since it's in factored form, all I really care about is if each parentheses is positive or negative. So all I'm going to do is just mental math. I'm going to figure this guy out using mental math. If you can't do that, feel free to use a calculator, so on and so forth. But for the first parentheses, negative 4 plus 1 squared, I don't care what the answer is. The answer is going to be positive. The second parentheses, negative 4 plus 3, it's going to give me a negative answer. The third parentheses, 2 times negative 4 minus 7 to the 4th power, is going to give me a positive number. And then the last parentheses, negative 4 minus 4, is going to give me a negative answer. And then all I have to do is figure out what's a positive times a negative times a positive times a negative. You worked all that out mentally, you're going to get a positive number. So I know for a fact that the very left region is positive. So let's use multiplicities to figure out the rest. So let's go from left to right. Going from left to right, the first x-intercept I approach is negative 3. Where in the work did the negative 3 come from? The negative 3 came from this portion. Notice it has an odd multiplicity. So as I cross the x-intercept, these signs here, as I cross the x-intercept of negative 3, these signs need to change. So it's going to go from plus to a minus. The next x-intercept we're going to cross is the negative 1. The negative 1 came here. Notice it has an even multiplicity. So even multiplicities, the signs do not change. So at x equals negative 1, from the left and from the right, it should stay the same. So it goes from negative, it will stay negative. Let's move on to the next x-intercept. The next x-intercept is 7/2. 7/2 came from this guy here. So it has even multiplicity, so it will stay the same. To the left, to the right, it will stay the same as negative. And last but not least, the x-intercept of 4. 4 came from this portion. It has an odd multiplicity, which means he will change from left to right. So since to the left it's a negative, I know he's going to go positive. So now that the sign diagram is complete, I'm just going to shade in all the portions of my answer. You look at the inequality. Notice how in this case it says less than or equal to 0. Well, what type of numbers, positive or negative, are less than zeros? Of course they're negative numbers. So we're going to shade all the regions that are negative. Notice how all these guys are filled in. So even though I do have 4 dots here, because everything is shaded in, it's as if this is one giant shading. So my solution, my answer, is everything between negative 3, comma, and 4. Notice we use square brackets because at the endpoints they were shaded. If the endpoints were open, we would have used parentheses. So that's the solution. Another situation where you need to use a nonlinear inequality is if you have a fractional or rational inequalities, right? So the technique, the idea, very similar. It's like 99% the same, but getting 0 on one side is still critical. Say, for example, I ask you to solve 5 over x plus 2 is greater than or equal to 4 over x plus 3. It's non-linear because we have fraction stuff, so let's use the same technique. We want 0 on one side. In this case, I need to move one fraction. Doesn't matter which place I move them. I sort of like to keep the x's on the left, so we'll go ahead and subtract this function over. So subtracting this function over to the left will give us 5 over x plus 2 minus 4 over x plus 3 is greater than or equal to 0. So now we have that 0 that we want. So now this is where rational inequalities are special. They have extra rules. We don't want 2 separate fractions. We want one giant clustered fraction. So we got to go back to elementary school. to add and subtract fractions, they need to have a common denominator. So I'm just going to multiply both fractions by the other's denominator. So I'm going to multiply the left fraction by x plus 3 on top, x plus 3 on the bottom. I'm going to multiply the right fraction by x plus 2 on top, x plus 3 on the bottom. Here's a little tip to you. Do not distribute up the denominator. Leave the denominator in factored form. So I'm going to distribute the numerator here. That's going to give me 5x plus 15 over x plus 3, x plus 2, minus distribute 4x plus 8 over x plus 3, x, there should be a 2 here, sorry, right there, 2, x plus 3, x plus 2, and then we have the inequality greater than or equal to 0. Notice how the denominators are the same now. Because the denominators are the same, I can go ahead and subtract these two fractions. Be careful when you're subtracting fractions. You need to distribute the negative to all of the terms here. So to merge them together as one fraction, x plus 3, x plus 2 on the bottom, we have 5x minus 4x is 1x. 15 minus 8 is 7. Positive 7. Positive 7. So there you go. You've made it so it's one fraction. The moment you have one fraction, you know how in the past our scratch work was, hey, pretend that it equals 0. You're going to do the same thing, except you're going to do it to both top and bottom. So here's your scratch work. I'm going to set the top equal to 0. And then I'm going to set the bottom equal to 0. So clearly the top is x equals negative 7. The bottom is x equals negative 3, x equals negative 2. And those are the numbers that you're going to plot on your sign diagram. So you have a negative 7, negative 3, negative 2. Now here's the key critical idea. Bottom equals 0 are always open on the number line. Even though this inequality has an or equals to, which means we normally shade it in, the answers you get from the bottom equals 0 will always be open. So negative 3 and negative 2 will be open because they came from the bottom. However, x equals negative 7 came from the top. The inequality has an or equals to, so we'll make him closed. But just as before, pick a number from the left region and plug it in to see if you get a positive or a negative answer. So I'm going to plug in, I don't know, x equals negative 8. So I'm going to save you all the work. It really is just plugging it into the inequality and see if you have positive or negative. So I'm going to fast forward through it. Just if you don't trust me, go ahead and check it yourself. Make sure I'm doing my math right. But if you plug a negative 8 into the inequality, you're going to get a negative response here. Negative, negative, negative. Yeah. So I'm going to put a negative up here. To fill out the rest, you just use multiplicity. So let's go from left to right. I'm going to approach a negative 7. Where in our scratch work did we get a negative 7? We got him from this guy here. Well, did this guy have any exponents? Did this parentheses x plus 7 have any exponents? The answer is no. So the exponent is always a 1, which is an odd multiplicity. Odd multiplicity means we change symbols. So from the left it was negative, it will change to the right positive. Let's keep moving on to the next x-intercept. So it's a negative 3. Where did the answer of negative 3 come from? It came from this portion of the problem here. Notice it has an exponent of 1, which is an odd multiplicity, which means to the left it will change. To the left is positive, it will change to the right negative. And then last but not least, going across negative 2, it has an odd multiplicity, so it will change. What regions, positive or negative, are we looking for? This is a positive region because it's greater than or equal to 0. So we're going to shade the positive regions. and then you just have to write your answer in interval notation. So there is our answer. The first region starts at -7, comma, and it ends at 3. Union, because of another region, that starts at -2, comma, infinity. So nonlinear inequalities, it takes a bit of work to create these sign diagrams, but trust me, it is a lot faster than trying to solve it directly. So nonlinear inequalities, if your inequality has anything more than just a regular line, you have to follow this process using sign diagrams.